So in this expression, we are required to find the value of x. There are many ways in which you can simplify this expression in order for you to find the value of x. But personally, I prefer to write all these terms. Sorry about that. So personally, I prefer to write all these terms as standalone terms. Remember, according to the laws of exponents, we know that if we are multiplying the same basis, say for instance we've got a to the power of m multiplied by a to the power of n is the same as a to the power of m plus n. So which means if we are multiplying the same basis, we add their exponents. So in order for us to simplify this expression or to break it down, 5 to the power of 4x plus 3 is in the form of a to the power of m plus n. But a to the power of m multiplied by a to the power of n will simplify our expression. So instead of writing 5 to the power of 4x plus 3, I'm just going to write 5 to the power of 4x multiplied by 5 to the power of 3, which is literally the same as 5 to the power of 4x plus 3, as we have explained the laws of exponents. If we are multiplying the same basis, we add their exponent. So we just had to revert this to the original expression. So looking at 100 to the power minus 2x plus 1, you could either also write it as in the form of 100 into the power of minus 2x plus multiplied by 100 to the power of 1. However, the problem will be going forward, because this is going to be 100, so this is going to be 125. You are going to multiply these terms because they are like terms. But the problem is, going forward, you still have to break down 100 so that it can have a direct relationship with the basis of 5. So it is better for us to do that at early stage so that we don't have a problem going forward. So we're going to need to try to create a base of 5 out of this 100. So in order for us to create a base of 5 out of 100, we're just going to say, if we have, say for instance, 5 to the power of 3, this is going to be 125, which is bigger than 100. So we're just going to try 5 to the power of 2 is going to be 25. 25 multiplied by 4 is going to be 100. So yeah, this is going to be 5 to the power of 2 multiplied by 4. So instead of writing 100, we are just going to write 5 to the power of 2, because we have now established the base of 5 raised to the power of 2 to represent 100. So our next step is going to be 5 to the power of 4x multiplied by 5 to the power of 3. So 5 to the power of x multiplied by 5 to the power of 3 is representing this. So we just revert this to its initial state before we add the exponents. So it is going to be multiplied by, so let us write this in brackets, so that 5 to the power of 2 multiplied by 4, or you can write 2 to the power of 2 is the same, and then to the power of minus 2x plus 1 is equal to 50,000. 50,000 is this one. Let me just cancel this for visibility purposes. So the next step will be multiplying the, what do you call, the exponents of whatever we have within the brackets with the exponents that we have outside the brackets. So this is 4 to the power of 1, because we know that any number to the power of 1 is that number. So instead of having 5 to the power of 2, we are just going to say 2 multiplied by minus 2x is going to give us minus 4x. And then 2 multiplied by 1 is just going to give us 4. It's just going to give us 2, sorry about that. and then 4 to the multiplied by minus 2x, so this is just going to be 4 to the power of minus 2x plus 1. So this is just going to remain as is to this number, and then the exponents of 5 are just going to be, instead of 2, it is going to be minus 4x to plus 2. So our next step is going to be 5 to the power of 4x multiplied by 5 to the power of 3 multiplied by 5 to the power of minus 4x plus 2 multiplied by 4 to the power of minus 2x plus 1 is equal to 50,000. So the next step will be to create a standalone terms from these numbers, and then write 5 to the power of 3 is going to be 125, so you're going to write 125 here. So it is going to be 5 to the power of 4x multiplied by 125 multiplied by 5 to the power of minus 4x multiplied by 5 to the power of 2 multiplied by 4 to the power minus 2x multiplied by 4 to the power of 1, which is literally 4, is equal to 50,000. 150,000. Oh, there's so the next step, we are going to consider these numbers. We have got 5 to the power of 4x, and then we've got 5 to the power minus 4x. So the bases are the same. We add their exponents. So it is going to be their exponents are going to be 4x minus 4x. 4x minus 4x is equal to 0. So 4x, so at the end we are going to have the base of 5 with an exponent of 0, and any number to the exponent of 0 is 1. So it is going to be 1 multiplied by this. So basically this is going to cancel with this one. And then we're going to write 5 to the power of 2 as is. So 5 to the power of 2 is going to give us 25. Write 25 here. 5 to the power of 4 to the power of 1 is just going to be 4. So our next step is going to be 125, this one, multiplied by 25, this one, and then let us just consider this one first because it is a like term with this one, multiplied by 4, multiplied by 4 to the power of negative 2x is equal to 50,000. Let us cancel this for a time being because we happen to find the solution for that. So the next thing will be to multiply this and this and this because they're like terms. 125 multiplied by 25 multiplied by 4. If you do that with your calculator, you are going to get 12,500. And then we keep this one. So it is going to be 12,500 multiplied by 4 to the power minus 2x. That is what we're going to be left with on the left hand side. So 12,500 multiplied by 4 raised to the power of minus 2x is equal to 50,000. So the next step will be to keep 4 to the power of 4 to the power of minus 2x on the left hand side. So for us to do that, we have to divide this number or this expression by 12,500 and also divide this by 12,500. So this is going to cancel this, and then we're going to be left with 4 to the power minus 2x is equal to 50,000 divided by 12,500 is just going to be 4. So at this stage we are able to see that the base on the left hand side, which is 4, is equal to the base, because like this is 4 to the power of 1. We just don't write that because any number to the power of 1 is that number. So the bases are equal. And according to the equality of exponents rule, we know that if the bases are the same, we can equate their exponents. So instead of writing 4 to the power minus 2x is equal to 4, it is just going to be the exponent on the left hand side, which is minus 2x, is equal to the exponent on the right hand side, which is 1. And since we are looking for x, we divide both sides by the coefficient of x. At this side we're just going to have minus 1, minus 2, and then also divide this side by minus 2. So this minus 2 is going to cancel with this one, and then we're going to be left with x is equal to minus 1 over 2. So our x is equal to minus half. So this will be our answer. Thanks for watching.